Hi, everyone. Thank you for attending DevSummit 2020. Our talk today is on IP selection and analysis made easy. I'm one of the presenters on this talk. I'm Pareena Verma, a Principal Solutions Architect at ARM.
And I'm the other presenter, Lasiuk, Senior Solutions Designer at ARM.
Thanks, Zach. So we've broken up our presentation today into two sections. In the first half of our presentation, we will present what the process of IP selection entails and how we've designed a new tool to make the process of IP selection a lot easier for SoC architects. So let's get started. So we here at ARM are built in a shared success model. We want to give system architects and SoC architects the freedom and flexibility to design with the right IP and make the decision with the right IP for their projects to achieve higher product margins, higher performance on their project at lower power. As you can see, there is a wide array of ARM IP ranging from application processors to embedded processors, interconnects, security IP, system IP. Now, for the system architect to make the decision on which IP to use for their project with a good degree of confidence, there are certain processes that we have put into place to make that process easier. So what does IP selection typically entail? We've broken up the process talking to customers and getting their feedback into 5 primary buckets. The first one is really functionality. Now, does the ARM IP have certain features like a DSP or security features that are required for their project? Does it have the right interfaces that are compatible with a list of other IP that they've decided to use on their SoC design? The second one ranges from some practical concerns ranging from things like the availability of the IP. Will the IP be available at a particular date given their project deadlines? And is the IP going to work at a particular technology node? So all of these factors go into the decision-making in the IP selection process. One of the most common things that architects look into is PPA, which stands for power, performance, and area. So will the IP that they have selected or the list of IP that they have selected meet the power, the performance, and the area budget? These are concerns that architects want to make sure that they have the right amount of confidence in before selecting their IP. The next 2 buckets range from some practical concerns like tools and support. Do they have the debuggers, the software stacks available in order to run their workloads on the IP and evaluate and make the right decisions? And certain commercial and financial aspects. How much does the IP cost? What are the royalties? What are the terms of use for the IP? Now, we found that X% of the users are able to make the IP selection decision based on the general data that's provided to them in the form of their research, either via the website, talking to the ARM FAEs, looking through technical reference manuals. But and then they're able to use that general data and continue on with their SoC developer journey. But then there is the Y% who would like to run their custom software workloads on the ARM IP and evaluate the performance of the IP before making the decision and continuing on with that SoC development journey. Now, this is the part of the problem that we are looking to make easier and solve the challenges in this area where users are able to very easily evaluate the performance of their custom software and make that decision right out of the box by running their workloads on the ARM IP. We call this problem the personalized IP selection. So how do we make this as seamless as possible? We have created a new tool that lets you evaluate the underlying ARM IP and gather your personal performance data by running your workloads But what this tool uses at the back end is proven technology that's been out there for years and decades that ARM users have been deploying. At the back end of this tooling is two abstractions of models. The first one is ARM fast models. ARM fast models are programmer's view models. As their name indicates, they run very fast. They're able to execute millions of instructions per second. And these models are really ideal for software development. They'll let you very easily understand new ARM architecture and design for the new ARM architecture, even before silicon or boards are available. For example, when ARM released the ARMv 8.1M architecture, we released the Cortex-M55 fast model. So users are able to quickly understand the new Helium vector instructions that are available on this architecture, validate their software even before hardware is available. These models are very good to prepare your software stacks and validate that your software stacks are ready before you can actually run them on any other backend to understand the performance in terms of the number of cycles of these software stacks. The second abstraction of models that is built at the back end are ARM cycle models. Now, ARM cycle models are very detailed models. They are 100% cycle accurate models of the ARM IP. They are compiled directly from the RTL source code. They are extremely useful for users to take their validated software stacks that have been running on their fast models, port that same software on the cycle model system, and now understand what is the number of cycles and the number of instructions that workload would take to execute on a particular piece of ARM IP. They are also used widely by partners to understand system-level performance analysis concerns like what is the SRAM utilization and memory and bandwidth utilization of your system. So using these two technologies that have been deployed to ARM ecosystem partners for decades, we have devised this new tool called the ARM IP Selection Sandbox, which is a quick and easy way for architects to evaluate ARM IP right out of the box and make their personalized performance data decisions as fast and as easy as possible. The main advantages of the IP Selection Sandbox is that it works right out of the box. So there isn't time spent in setting up tools and setting up the environment. You're able to get to your answers right away. An architect is able to drive the analysis of these results using any preferred mechanism, whether it's through the web-based browser or through a command line interface. The other significant advantage of the IP Selection Sandbox is users can port their own custom workloads and not just industry standard benchmarks, but really their own workloads that they're looking to evaluate on the IP very easily and very seamlessly onto these fast and cycle model systems. And this is done by providing optimized boot code for all of the A, R, and M Cortex series systems that are provided in the IP Selection Sandbox. We also provide templates for software examples, which makes it easy for the software developers to port their own custom workloads right out of the box. The third and the most significant advantage is the time to results. So while it works out of the box in terms of setting up your environment, you're able to port your custom benchmark code. The most important part is you're able to get the results for your custom code right away. So you're able to analyze several different granularity of results ranging from high-level metrics such as instruction counts and cycle counts that it takes for workloads to run on ARM IP, to mid-level statistics such as bandwidth utilization and memory utilization in a system, to very low-level analysis such as how many cycles did a particular loop in my software function take to execute. So using these three pillars of strength of the IP Selection Sandbox, we've made the process for architects to gather their customized performance data as easy and simple as possible. To illustrate the usage of this tool, Zach will now present a demonstration in a tangible use case of how the IP Selection Sandbox is deployed. Over to you, Zach.
Thank you, Pareena. Great overview. So now, as Pareena said, I will dive into a use case in practice. This is a made-up example, but it's based heavily on experiences that we've had with customers using this tool, and is based on some of the pains that we've seen some users have before using this tool and working to fix them. So we'll step into the shoes of a design house. So this is a fictional design house called Advantage Design, and they have been contracted by an OEM called Mood Lighting to create a new project for them. So this example, we're stepping into the design house's shoes, but it could very well be an OEM with an SoC development team. It could be another design house. It could be SIPs that are designing their own SoC. But in this example, we'll be going with the design house. So the OEM customer, Mood Lighting, hands Advantage Design this project brief, and it outlines that they would like them to work on the Mood Matcher LED project and do an initial SoC investigation. So this product itself, the Mood Matcher LEDs, it senses the mood of the people in the room by detecting their speech characteristics and body language, analyzing them, and matching the mood or the lighting in the room based off of the mood of the people in it. So the current product, fictional product, is built around an off-the-shelf SoC based around a Cortex M7, and it has more functionality than is desired. It's currently shipping around 5 million parts per year. So the goal of the project that they would like Advantage Design to take on is that they'd like them to define an SoC to achieve lower product price, less latency, with more data security to handle the sensitive customer data that they're working with. So with this project brief, Advantage Design hands this to their system architect, Tom Afton. So Tom is an experienced systems architect, been working at the company for about 5 years, experienced in SoC design, and has used ARM several times in the past. So he's leading a small team on this SoC investigation project and is hoping to complete it thoroughly and faster than expected to impress Mood Lighting and secure the full SoC design contract, as this is just the initial investigation to get the block diagram of IP to use in the actual SoC design. So what is the first thing that Tom would do? It would be to go out and find the general data that he's trying to make decisions between various IP. So here, starting with the Cortex M7 as his current example, he'd like to work from and compare against similar IP. So he selected the M4, the M7, and the M55 to compare and contrast against each other. And he's collected this data in a spreadsheet on performance metrics and security information from around the web, talking to ARM FAEs, and conglomerating it into this spreadsheet. So looking down at the M4 compared to the M7, it looks like the DMIPS and the core mark scores aren't nearly close. The pipeline isn't as high. It doesn't have a double precision floating point. It doesn't look like it can match the performance of the M7, and he needs to increase the performance. So the M4 is a no right off the bat. So the M7 is the baseline that they're deciding to go on. It has the best performance in this area, but it doesn't have security based on the trust zone security architecture that the M55 has. But it's currently being used in the SoC in production, so that's given the green light at least to move on to the next stage of investigation. The next one to consider is the M55. And looking over at the performance metrics, the DMIPS, the core mark score, The pipeline stages, those aren't up to the same standard as the M7, but it has an option for vector floating point unit, and that's the helium technology that Pareena mentioned earlier in the presentation. And that significantly improves the performance of machine learning oriented workloads. So the M55 actually could perform better based on the workloads that Tom has. And since his product is heavily using machine learning workloads to analyze the speech characteristics and body movements of people in the room, the M55 could be better than the M7. It could be the same or it could be worse. He needs to get more information to find this out. And as for security, M55 has an option for trust zone, so that's a leg up over the M7 already. So he decides to compare the M7 and the M55 based on his custom workload to see apples to apples which one runs faster to make an informed decision. And he does that by leveraging the IP Selection Sandbox. So here we have a video that runs through how Tom uses it. It's about 2 minutes long, so I'll give a quick precursor before starting it. The general steps are as follows. He downloads the package, of course. He untars it, no real installation necessary. He goes through and looks at the different systems that are involved that are provided out of the box based on both fast model and psychomodel technology. He goes to the M7 and selects some options and selects the dry stone benchmark to start working with. So he can upload his own software, but to start, he's using a piece of software that's compiled and works right out of the box. Next, he goes to now he goes to the M7, previously was the M55. Same benchmark, comparing apples to apples, and starts the simulation. So it kicks it off. It gives an estimated time to completion for each run, but we go to a previously ran simulation for the demo purposes. And you can scroll through comparisons at various levels, a high-level comparison, mid-level comparison, and then low-level analysis getting into the details of each particular simulation run. So this is the M55 running dry stone, booting from RAM. And you can view all the cycle count, instruction count, where he spent the most time booting, where he spent the most time in his actual code, the benchmark itself, as well as the low-level terminal output for any printfs or debug statements or anything else that he'd like to add. So that video is an example of Tom running an out-of-the-box benchmark that just works right away. But he also has the option, as mentioned before, to utilize some boot code templates that are provided in the package, optimized boot code that Tom just has to import his own main.c, his machine learning main, compile it with the included ARM compiler 6 or GCC compilers included in the IP Selection Sandbox will show up in the GUI, and he can do the same process again. Select the M7, M55, his custom benchmark, simulate it, and view the results. So he completes that, runs dry stone, runs a few more different benchmarks, and he ultimately comes to the conclusion that the M55 makes more sense with his machine learning oriented workloads, and he has the data to back it up. So in summary of what Tom went through, this is the amount of time that he saved using the IP Selection Sandbox. So because he didn't have to set up his tool environment, all the compilers, the libraries, the benchmarks, the optimized boot code, and the systems, they're all packaged together and they work out of the box. Instead of taking a week or two to set up, it takes 0 days. And then it's the system. Instead of having to build his own custom system, learning how to work with models, fighting Verilog code to stitch it together, he's provided with an optimized system, pre-stitched as a fast model and psychomodel system, ready to simulate out of the box, going from saving months to 0 days. Lastly, porting his custom workload. The optimized boot code that was provided enabled him to very, very quickly put in his benchmark that he cared about without having to worry about the low-level details, saving weeks of time and going down to less than a week, around 3 days. So alongside the time saved and doing faster IP evaluations, this IP Selection Sandbox also increases the confidence of Tom and anyone else who uses it that they make the right decision with the right IP and move forward with their design with the right IP in mind. So those are the main benefits of using IP Selection Sandbox. We've seen it work in practice. Now, how do we get it? You can download it in 2 different ways. It's free to use and free to trial. So if you're part of the ARM Flexible Access program, it's available through the Product Download Hub. And you can go there, look for the Flexible Access Models package and download it straight away. If you're not a part of ARM Flexible Access, you can go to the IP Exchange website, which is ipx.arm.com, and you can search for the Tools section, and it will come up under IP Selection Sandbox. We encourage you to reach out to us for questions on this or help getting started. We're happy to help you out to make your IP selection process as easy and as painless as possible. Our email is on the screen there, armtoolsolutions@arm.com. So that's what we have for you today in this presentation. We hope you enjoyed it, and we hope you got a lot out of it. Anything you wanted to conclude with, Pareena?
No, thank you, Zach, for your presentation, and thanks everyone for making the time to listen to our talk on IP selection analysis made easy. Feel free to reach out to use the tool, or if you have any feedback on making this process even more easier. Thank you.
Thank you.